Welcome, learner, to today's deep dive. Today is August 24th, 2026, and, well, we are looking at a massive shift in how artificial intelligence interacts with our personal data.
Yeah, a really massive shift. It literally just dropped.
Exactly. Our mission today is to thoroughly explore this brand new release, a framework called AI Context version 1.0.0.
Right, and it's definitely a lot to cover.
It is. So to accomplish this mission, we are pulling from a highly detailed stack of sources today.
Yeah, we've got the official Zenodo release record.
Right, that's DOI 10.5281 Zenodo.2208189, for those keeping track at home.
And we also have the primary GitHub repository documentation under QSOL-KCB, along with these incredibly dense release notes.
So dense. And a scholarly overview PDF on top of all that.
It is a remarkably complete set of documentation, which, is fitting for software that basically completely re-engineers personal data sovereignty.
Yeah, and there's a fascinating detail right up front in that Zenodo record.
Oh, the code contributor thing.
Yes. The creator of this framework, Trent Slade, actually lists his co-contributor for the architecture and implementation as OpenAI ChatGPT.
Specifically the GPT 5.6 SOL model, yeah.
Right. So we have an AI helping to build the very framework designed to put, strict, uncompromising guardrails around AI.
Kind of ironic, but also brilliant.
Okay, let's unpack this. Because this specific framework is a complete game changer for anyone who has ever worried that their AI assistant is either forgetting important details or, maybe worse, remembering things it definitely shouldn't.
Right. Usually when we talk about AI memory, there's this expectation of total photographic recall.
Yeah, like you just dump your files into a prompt window or you sync your cloud drive.
Exactly. And you just assume the AI has perfectly absorbed it all into this bottomless bucket.
Which is an incredibly opaque way to manage your digital life, right?
It really is. We love the convenience of that bottomless bucket, but we have absolutely no idea how that information is actually being stored.
Or how it prioritizes contradictory facts.
Exactly. Or whose servers that data is bouncing around on.
Yeah.
So to understand why AI context is so revolutionary, we first have to understand that messy reality.
Yeah.
Right now, if you use a major provider, your memory is stored on their side.
Right, it's locked in.
Yep, it's non-portable, and it's governed by their black box algorithms.
I always picture it like a hoarder's garage.
A hoarder's garage. That's
Yeah.
a good way to put it.
Yeah, you just back up the truck, your email archives, your old AI chats, your Google Drive takeout, and sweep it all into the dark.
Just toss it all in there.
Right. And whatever the AI happens to trip over when you ask it a question, it uses to answer you.
That visual captures the problem perfectly, and, it leads right into the foundational philosophy of AI context.
Which is?
Instead of that chaotic garage, this framework treats memory as a user-governed local data system. It aggressively separates the idea of raw data from accepted fact.
Oh, interesting. How does it actually do that?
Well, the architecture accomplishes this through a very strict pipeline.
Okay.
It starts with your private sources, which go into a raw vault.
Okay, raw vault.
From there, an import phase generates cryptographic receipts, moving the data into a staging area.
Wait, hold on. Let me stop you at the import phase.
Sure.
If I import a massive, say, 50 gigabyte Google Drive takeout file into the system and it's sitting in that staging area, you're saying the AI doesn't actually consider any of that data to be a memory yet.
That is a core invariant stated right in the source documents.
Mm-hmm.
Source material does not equal canonical memory.
Wow. Not at all.
Not at all. Just because an old text document or a chat log is imported, the system merely considers it evidence.
Evidence. Not a fact.
Right. It is an unverified observation.
Yeah.
It is actively shielded from the AI's reasoning engine until it is explicitly approved.
So if the current ecosystem is a hoarder's garage, AI Context is building a highly curated museum exhibit.
I like that.
Yeah. Like, the artifact might be sitting in the loading dock, the staging area, but it doesn't get a plaque and a spotlight in the canonical memory exhibit until the human curator says it belongs there.
Exactly. And that curation process is rigorous.
What does it involve?
It involves conflict handling, verification, checking for supersession.
Supersession.
Yeah, where a new fact mathematically replaces an old one. And explicit tombstoning for data that needs to be permanently killed off.
Okay, I have to push back here on the practicality of this.
Okay, get it.
The entire benefit of artificial intelligence is that it can process massive amounts of raw data for you.
Right, for speed and scale.
Yeah. If I have to sit in front of a terminal user interface manually approving every single line of data from a 50 GB import just to move it from staging to canonical memory, I mean, I am creating a massive, impossible bottleneck for myself.
That sounds like a nightmare, yeah.
I would spend my whole life just curating data instead of actually using the AI.
Well, the developers were acutely aware of that exact tension. The framework doesn't force you to do all the heavy lifting manually.
Oh, thank goodness. How does it bypass that?
During that curation phase, AI context utilizes automated semantic extractors and local on-device LLMs.
Okay.
These tools can crawl through that massive Google Drive dump, identify entities, map relationships, and extract clear, factual claims.
And just put them in memory.
No, to propose them as candidates for memory.
Okay, so the machine is doing the reading. It reads an email, extracts a claim like user moved to Seattle in 2021, and writes up a proposal.
Exactly.
But it can't just slide that proposal into the database as a fact on its own.
What's fascinating here is how the framework enforces the boundary of authority. The rule is absolute. An LLM suggestion is not a review decision.
I
The machine can generate 1,000 perfectly formatted JSON proposals based on your emails. But the machine mathematically cannot self-promote those candidates into canonical memory.
So a human still has to say yes.
Right. Human approval, or an explicitly defined automated policy approval, is a separate, required authority event.
By decoupling the suggestion from the approval, you're basically ensuring that an AI hallucination, like if an extractor incorrectly summarizes a complex legal contract.
Which happens all the time.
Right. You're ensuring it doesn't silently become a permanent foundational fact in your personal system. It just sits in staging as a proposal until I look at it and say, yes, that's true.
Exactly, because once it enters canonical memory, the system treats it as a proved reality.
But, having a perfectly curated offline museum is essentially useless if you can't actually show the exhibits to an AI to get work done.
True.
The moment you connect this local, pristine vault to an external cloud model to ask it a question, aren't you risking everything?
Well, that is a big concern.
I mean, I might want my local AI agent to help me draft an email, but I definitely don't want to send my tax returns to an external provider's servers.
And this is where the framework introduces the concept of selective disclosure. It acts as a routing firewall.
A routing firewall. So
Yeah.
we've got the curated museum, but now we've hired an incredibly strict bouncer for the VIP room.
Right.
Just because a piece of data is in canonical memory, meaning it's on the guest list for the building, doesn't mean it gets into the specific context bundle that is handed over to the external AI provider.
That bouncer operates on the principle of least privilege. The routing system in AI context is a read-only disclosure firewall.
Okay.
It dynamically builds what the documentation calls the smallest permitted context bundle.
Smallest permitted. Based on what?
It evaluates several mechanisms simultaneously. Your user profile, the specific task tag, hard exclusions, sensitivity ceilings, and the target policy.
The target policy being the specific AI model you are querying at that exact moment.
Right. A crucial distinction in the GitHub ReIG is the difference between target classes.
What are the classes?
Well, if you are building a context bundle for a local default target, which means an open source model running entirely on your own laptop, CPU, or GPU.
So it's totally offline.
Exactly. For that, the policy might permit highly private, sensitive records to be included because the data never leaves your hardware.
Makes sense.
But the framework mandates that bundles built for local targets must never be forwarded to an external provider.
Oh, wow. Hard block.
Yes. If you switch to an external cloud model mid-task, you have to reroute. The firewall builds a completely new bundle, stripping out all the sensitive records based on the external provider's stricter policy.
Wait, I have to stop you there with a real-world edge case.
Okay, let's hear it.
Let's say I'm paying an advanced external AI to debug a complex script for me, and the bug is actually located inside my proprietary API key integration.
Okay.
If your firewall blocks my API key because it hits a sensitivity ceiling, the AI literally cannot see the problem. It fails to do its job.
Right.
Why would I want software that neuters my AI when the AI explicitly needs that specific file to give me the answer I asked for?
It's a completely natural frustration, honestly, but the framework explicitly rejects that argument.
It does.
Yes. The core rule, hard-coded into the routing firewall, is relevant does not equal permitted. Dependency never, ever bypasses permission.
Even if it completely breaks the query.
Especially if it breaks the query. The system fails closed.
Wow.
If the external provider needs a file to solve a problem, but that file exceeds the sensitivity ceiling for external disclosure, the AI simply doesn't get it.
Its own compromise.
Very. And, AI context actually supports deterministic vector and graph indexes to act as retrieval accelerators.
Okay, so searching is fast.
Right. So when you ask your question, the vector database turns your words into mathematical coordinates, searches the space, and might find a perfect mathematical hit for your query.
But finding those coordinates is only step one.
Precisely. The framework states clearly that index membership is not disclosure permission.
Right.
That retrieved candidate from the vector database must return backward through the canonical validation and routing firewall.
Before the AI ever sees it.
Yes. The firewall checks its tags. If the tag says local only and the query is headed external, the perfect hit is just dropped. Useful context does not automatically acquire authority just because it matches a search query.
Okay, so we've covered how facts get approved into memory, and we know how the firewall blocks them from leaving inappropriately.
Right.
But where do these facts physically live? If this entire system is local and governed by me, how do I protect the database itself from being stolen?
Good question.
And how do I take it with me if I buy a new computer?
Well, the persistence and portability layers handle the physical reality of the data. For protection, the framework offers an optional encrypted directory backend.
What kind of encryption?
It utilizes AES 256 GCM encryption through a maintained Python cryptography package. This means your data is heavily encrypted at rest.
Which brings up a massive limit outlined in their own threat model documentation. I was reading this and I did a double take.
Oh, the password manager warning.
Yes. If this framework uses military-grade AES 256 encryption, why are the developers explicitly warning me not to use it as a password manager?
It seems contradictory at first.
It really does. If it's secure enough to hold my entire digital worldview, why isn't it secure enough to hold my private keys?
This raises an important question about the difference between storage security and system purpose.
Okay.
The strict boundary defined in the threat model exists because encryption at rest grants no epistemic or disclosure authority.
Break that down for me. What does that actually mean in practice?
It means that just because the data is locked up safely on your hard drive doesn't change the fundamental mechanism of what the software is designed to do.
Which is share information.
Exactly. AI context is a pipeline explicitly built to eventually feed context to an AI. Even a local AI is an external processing agent.
Right.
Putting credentials, recovery codes, or private keys into a system whose fundamental architectural purpose is to surface and disclose information is a critical security risk.
Ah, I get it now.
The framework enforces the rule. Key ID does not equal key material.
I think I see what you're saying. You don't put your actual social security card on display in a museum exhibit.
No, you definitely don't.
Even if the museum has incredible security guards and thick vault doors, the entire point of the museum is to show things to people. You might put up a plaque that says, "The curator possesses a social security card," but you don't display the card itself.
That is exactly the distinction. The system can know that you have a key to maintain context, but it should never memorize the key itself.
Okay, so that handles security and boundaries. What about portability?
They manage portability through what are called .aicr archives, AI context restore files.
.aicr.
Okay, these files preserve your governed, curated memory so you can easily move it between machines or sessions.
So the .aicr file is essentially a U-Haul for your digital brain.
Yes, exactly.
You can pack up your curated life and move to a completely new house, meaning a new AI vendor, but you are strictly packing your furniture? You are absolutely forbidden from bringing the old house's wiring or plumbing with you.
The wiring and plumbing being the AI's internal mechanisms, yeah. The docs emphasize that restoring from an AICR file is about context reconstruction, not model identity reconstruction.
Interesting.
You are packing up your pure, verified facts. You are not bringing the previous AI's hidden reasoning states, its neural network weights, or any invisible memory the provider might have kept on their side.
You plug your pure facts into the new house's plumbing.
Precisely.
Which makes you entirely vendor independent. But maintaining that pristine list of facts brings up a really highly specific technical detail in the release notes that I need you to explain.
Oh, the canonicalizer.
Yes. The team made a very deliberate choice about how they standardize or canonicalize the data in this 1.0.0 release.
Right, we just stuck with the old one.
Exactly. They deliberately kept an older canonicalizer called Python JSON v0.1. They actually evaluated a newer standard called RFC 8785 JCS, but they explicitly rejected it. Why would you build a cutting-edge AI framework and reject the newest standard?
Well, to understand why, we have to look at the mechanism of canonicalization itself. When data is stored, things like whitespace or the order of keys in a JSON file, like whether name comes before age or vice versa, can vary.
Sure.
A canonicalizer forces a strictly standardized format so that identical data always produces the exact same cryptographic hash.
The hash being the unique alphanumeric string that acts as a receipt for that specific piece of data.
Correct. The release notes explain that if they silently change the canonicalizer to the newer RFC standard, the same piece of data would suddenly be ordered slightly differently.
Just a tiny shift in whitespace or order.
Right. And that slight change would generate a completely different hash.
Oh, and if the hash changes, you lose the proof of the data.
The entire chain of provenance and cryptographic receipts would break. The system would no longer be able to prove when or how a fact was approved.
Wow.
So they prioritized the absolute stability of the historical receipts over adopting a newer standard. They noted that any future change to the canonicalizer will require a massive, explicitly designed migration path to recalculate the hashes without losing provenance.
It shows an obsessive level of dedication to data integrity.
It really does.
But it leads me to my final, biggest question.
Okay.
All of these rules, the routing firewalls, the hash provenance, the strict separation of staging and canonical memory, they are ultimately just code.
Okay.
Code written in Python and Rust. And code has bugs.
Oh.
So how do we know these pipeline rules are actually enforced under the hood?
This leads us to arguably the most rigorous and unusual part of the entire V1 Waterpolo 0 release, which is the Phase 12 formalization.
Here's where it gets really interesting. Because they didn't just write unit tests to see if the code worked.
No, they went way beyond that.
They went to the trouble of mathematically proving their software. The developers used a formal verification language called Lean4.
Right.
They proved 35 named theorems targeting the exact frozen Git commit of this release. The commit hash is 53D7069B face6 AV605B6A5man5D6AD60KEC66572A, and they proved it with 0 sorry or admit placeholders.
That's the big deal.
For anyone who isn't a computer scientist, what does that actually mean?
Well, formal verification is not just a unit test checking if an input produces an output. It is a mathematical proof that a specific state machine cannot legally transition to an invalid state under any circumstances.
It's physically impossible.
Right. It forces the compiler to physically reject the code if the reel can be broken. It is exceptionally rare to see this level of mathematical rigor in personal consumer software.
But reading the release notes, the developers spend almost as much time listing what they didn't prove as what they did prove.
That's very true.
They explicitly state they didn't prove every Python or Rust implementation detail. They didn't mathematically prove that AES GCM encryption works. And most importantly, they didn't prove the semantic truth of the content.
Yep.
So why go through the painstaking effort of Lean4 formalization just to constantly downplay what it actually achieves?
If we connect this to the bigger picture, this approach is actually the absolute gold standard for reproducible software and AI safety.
Really? How so?
In the software world, marketers often use the term formally verified to imply that a program is magically perfect and unhackable.
Right, like a buzzword.
Exactly. The AI context team is actively preventing accidental overclaims. They used Lean4 to prove structural invariance.
Structural invariance like what?
For example, Theorem 10, unresolved conflict does not equal application authority. They use mathematics to prove that the architecture structurally cannot allow a piece of data to become canonical memory if there's a pending conflict flag attached to it.
So the pipeline rule is mathematically flawless. So they've essentially mathematically proven they built an impenetrable vault door, but they are very openly admitting that mathematics cannot prove if the gold inside the vault is actually real.
That is the perfect summary. Mathematics cannot guarantee that a string of text imported from an email is objectively true in the real world.
It just knows it followed the rules getting in.
Exactly. Furthermore, they were so rigorous about this boundary that they strictly separated the source code from the proof layer in the Zenodo archive.
Oh, in the file structure.
Yeah, the reference -v1.0.0 directory is physically separate from the formal directory.
Which proves that the Lean4 files were created and verified after the code was frozen. So no one can accuse them of baking the proofs into the original tag just to make the architecture look better than it was.
It is a masterclass in separating authority and provenance. They're defining exactly what mathematics can and cannot do.
It is so refreshing to see a tech release that actually tells you the absolute mechanical limits of what it can do instead of just promising to solve all your problems with magic.
It really is.
Okay, so what does this all mean for you, the learner? AI Context V1.0.0 isn't just a new piece of software, it really is a paradigm shift.
I agree completely.
It forces us to start treating our AI as a bottomless dumping ground for raw data, hoping it figures out our lives for us.
Yeah.
It forces us to start treating our AI as a highly governed consumer of a reality that we meticulously curate.
It puts sovereignty entirely back in the hands of the user. You hold the cryptographic keys and the mathematical proofs to your own digital context.
And that leaves me with a final thought for you to mull over. We've talked extensively about how AI context strictly separates factual authority from just raw AI memory, and how you can pack up your pure facts into that .aicr file.
Right.
Imagine you install this today. You spend the next 10 years meticulously curating this vault. You resolve conflicts, you tombstone bad data, you curate your exact preferences, your history, your verified knowledge.
That's a lot of curation.
It is. But does that portable file eventually become a more accurate, objective map of your personal worldview than your own human memory? We all have foggy memories. We forget things, we misremember events, we change our minds. But this file wouldn't. It is a mathematically proven, cryptographically hashed record of everything you have ever declared to be true.
That is a wild thought.
And if so, when you eventually pass that file on to a family member, or perhaps a future AI long after you are gone, are you essentially passing down a digital replica of your exact perspective on reality?
It really makes you think about what you put in the vault.
It does. Think about what you are letting into your vault, learner. Keep questioning your inputs, keep curating your reality, and thank you for joining us on this deep dive. We'll see you next time.